Hello everyone, my name is Ashwir Singh and today we are going to discuss one another topic of vehicle dynamics, that is introduction of vehicle dynamics. So before starting with the topic, let's discuss what is basically a vehicle dynamics. So as we know, dynamics come from the term which is the calculation of forces on any subject, on any object which is acting under the influence of that forces. So in the same context, we are going to discuss the dynamics of a vehicle. As we all know that there are certain variables and factors which are going to affect the forces which is acting on a vehicle while the vehicle is running. So in this particular section we are going to discuss the basics of these dynamics and what are the references and what are the basic concepts we are going to take into consideration while discussing the vehicle dynamics. So let's begin. So, in today's lecture, we are going to cover up the few topics like the concept of lump mass, vehicle fixed coordinate system, and earth fixed coordinate system, then the motion variable system, Euler relationship between the Euler angles, and the force system acting on the rigid vehicle. So basically, the vehicle dynamics consist the action of forces and the magnitude and the direction of these forces on each subject and each component. So as we know that a vehicle is a combination of various systems individually comprising different components within these systems, like suspension system involve the damper, the axle, wheel, and the mounting on the chassis. Similarly, engine, the driveline consists of engine, transmission, and the mounting. So in that context, we are going to discuss what is a lump mass. So all these systems have their individual functioning. So overall, with the combination of these system working in the synchronized method, uh, a vehicle is working, or we can say a vehicle is running. So in that case, what is a lump mass? As we know, in a vehicle there are some components, or you can say some machineries are mounted individually on the chassis. So for example, on chassis we mount engine, we mount transmission, we mount suspension system, we mount some seats, that is for passenger cabin, the frame, and some other components. So each of these components having their own mass, and each of the mass will comprise its own center of gravity. So in that case we have to discuss what is the influencing center of gravity which is going to affect the dynamics of the vehicle. Because if we are going to discuss all the components and individually their center of gravity, it will make the system very complex and the calculation very complicated. In that case we have to pick some of the factors which going to affect, or we can say that the which are going to influence the system for their dynamics. So in that case we have to introduce a concept of lump mass. So taking the consideration of influencing masses individually and considering these masses as a whole, and combination of these masses, we have a common center of gravity upon which we going to calculate the dynamics of the vehicle overall. So what is a lump mass? The motor vehicle is made up of many components distributed within its exterior envelope, that is the vehicle. Then all the components having their own significant weight and thus having their own center of gravity, that is we all discussed already. Then uh, for vehicle analysis, all these parts components are considered as a single lump mass. That means all the influencing factors or all the influencing masses will mounted on a vehicle. So in that case, by the combination or the assembly of a vehicle, that will overall vehicle will act as a single mass. So if it is acting as a single mass, it has to be have a single center of gravity. So that center of gravity will be significant for the further calculation and simplification of the complex equation which are involved in the calculation of vehicle dynamics. Then for ride analysis, it is often necessary to consider wheels are separate lump mass, because wheels are supported on the surface, that is road surface, and they are not sprung into the vehicle. So there are basically, we can say, the vehicles having a support on wheels. So in that case, wheels are considering as a separate lump mass. In that case, lump mass represented by bodies is considered as sprung mass, and the wheels are denoted as unsprung mass, because it is not hanging with the chassis. They are directly supporting on the road surface. So as we can see in the figure, that is an example of a system which is having a base, several beams, and each beam have its own weight, so considering as it as a lump mass. So in that case, if all the components and engine, it has its own weight, transmission will also have its own weight. So we cannot calculate the dynamics related to the engine individually or transmission individually. We have to consider it within the exterior envelope of a vehicle, and that in that case, it is act as a single mass, that is called as lump mass, and which is distributed on four wheel support in case of four wheel, and two wheel support on the case of two wheel. Then before going to calculation, that there are two concepts which is related to the location and the stability of a vehicle, that is vehicle fixed coordinate system, and another is the earth fixed coordinate system. So in vehicle fixed coordinate system, what we do, we take in consideration three mutually perpendicular axes which denotes the linear and rotational change in the position of a vehicle. So vehicle fixed coordinate system, what is it? It is the coordinate system which is located on the vehicle center of gravity and changes with the location and the stability of a vehicle. So vehicle motions are defined with the reference to a right hand orthogonal coordinate system which is originated at center of gravity and travel with the vehicle. So the vehicle fixed coordinate system will always travel with the center of gravity of the vehicle. And earth fixed coordinate system is it's generally called as the global coordinate system, which is earth fixed coordinate system which do not changes its position, and its center it is on the center of the earth. So we can say, if we are going to analyze any of the vehicle location, we have to check two different coordinate system and the changes of their axes linearly and rotationally, with the reference to a fixed coordinate system, that is earth coordinate system or global coordinate system. So vehicle attitude and trajectory through the course of a maneuver are defined with respect to a right hand orthogonal system, that is fixed coordinate system. So the location of any vehicle with respect to global fixed coordinate system, or we can call it as earth fixed coordinate system, is always defined with the help of the relation between earth coordinate system and vehicle coordinate system. So that is all for today. We'll discuss few other topics in next lecture. Thank you.